Welcome back to the CAMX Demo Zone, brought to you by Composites One and the Closed Mold Alliance. The demo today, we're talking about thermal expansion molding, and it's one of our newer supplier partners to the Demo Zone, L&L Products. I'll go ahead and introduce L&L. We have Dennis, Jason, and Ken. What we're going to be doing today is molding some coasters with one of their unique products, the InsituCore. So I'll go ahead and hand it off to the L&L team.
Thank you. All right. Okay, here. All right, welcome everybody. We're going to do a short demo to show everybody how this material works. And then I'm going to get into more detail about the different versions of the product, some of the applications, and basically the benefits of using this product versus some of the conventional methods of foam core manufacturing. So right now, as you can see up on the camera, Ken is laying up some layers of some pre-impregnated carbon fiber. So he's putting down a bottom layer in the tool. That bottom layer is slightly larger than the final part. And what he's going to do, he's going to go and he's going to fold those edges over so that the edges of the final part are going to be closed out as well. Before he puts the top half of the tool on, he's going to take a very thin layer of our thermal set version of InsituCore. This is a very thin layer. It's going to, under heat, it's going to expand, and it's going to push those carbon fiber pre-preg layers up to the tool surface. Within our tool, you can see that we have our InsituCore logo in the tool. That will also show up in the final part. So again, for this molding process, we're trying to make a net-shaped part in a single step. So once he's done laying this up, he's going to bolt the tool together, put it into our press, and you'll notice this is a very inexpensive heat source. It's a t-shirt press. So really all you need to make these composite parts is a closed mode tool, a heat source, and that heat source could either be a heated press like this, it could be an oven, it could be a electronically or water heated or oil heated tool. So as long as you have that heat, it'll cause the material to expand. Once the material expands, then the carbon fiber, the epoxy system in the carbon fiber is going to cross-link, lock that into place, and create a rigid final part. So as Ken's getting his final steps done to bolt up this tool. And as far as the cooling process, that's also very simple. He has a bucket of water. When he takes the tool out, he's going to put it in the bucket of water. And then the next tool could go into the press. So you don't have to wait for the cycling of the tool, to ramp up the temperature and then cool it down. He's going to just take that out, and because the tool is bolted together, the part will stay intact, and he'll take that apart after it comes out. So he's going to bake this for about 10 minutes, and as he does, I'm going to talk a little more detail about the product line itself. So InsituCore is not just a single product, it's a family of products. We have both a thermal set and a thermoplastic version. It's supplied in sheets. So the customer, if they're using the thermal set material, that comes with a release liner on top. You peel the release liner off. You can use a table to kit cut your parts to the general dimension of your final part. That's placed in the tool just as Ken did, and you can use whatever type of reinforcement layers you want. So it could be a carbon fiber pre-preg, a glass pre-preg. With the thermal set version, you can even use a dry fabric. There's enough residual resin in our formulation that when it expands, it'll wet out those dry layers, and when it cross-links, it'll create a rigid surface just like a pre-preg. So again, we're trying to simplify the process. If you think about conventional foam core composite manufacturing, typically the manufacturer is going to purchase a pre-cured foam. They're going to take that to a CNC mill. They're going to, start with a large block of foam, and they're going to machine that to the dimension they want. Then they're going to add their reinforcement layers, put that into a tool, and use compression and heat to form that. So that's sometimes very expensive equipment depending on the tonnage required to mold that part. We're creating the pressure internal to the tool with our InsituCore foam. So the foam is also adhesive. So in the case of our thermoset material, it'll bond to a variety of substrates, your typical carbon fibers, glass, things like that. If you're working with thermoplastic face sheets, like polypropylene, you would want to use the thermoplastic version. So the thermoplastic version is dry to the touch, so it doesn't require any release liners. It can still be kit cut to the shape that you want. If you know the volume of your tool cavity, you can calculate the weight of material you're going to put in before you bake it, and you're going to very consistently hit the final density that you're looking for. So that's just a simple calculation, and you can get to, say if you wanted a 0.1 gram per cc density, and you have a 1,000 cc tool, you put in 100 grams of material, your final density is going to be 0.1 grams per cc. So very simple to calculate. The other thing that's unique about this product is you can put it through a second bake cycle and it will expand again. So where that comes in really handy is if you wanted to do a two-step process. So if you have a very complex shape, or if you want to lay your fabric up at different angles, sometimes it's hard to lay up in the tool, right? So what you would do is you would put the foam in the tool, make a mandrel, then lay up your reinforcement fabrics, wrap your edges, do everything you need to do, get all the angles that you want, then put that part in the tool, put it through a bake cycle. The material will expand a second time and create the pressure needed to consolidate those layers. So very versatile product, and in this case you can see, we start with the foam, and the final product, this is what we made these dump tray samples as a demonstration. This would be something that you put on your desk to throw your keys and wallet in, kind of a desk organizer. So again, very, very nice finished surface and a very easy step. So we mentioned with the conventional method of machining. You think about that, you have a very expensive piece of equipment like a CNC mill that's tied up, right, that could be doing other things. You have the material waste that's generated because you're purchasing a foam and then machining it away, and you have to do something with the dust, either landfill it or reuse it somehow. But you're cutting out that step. You're reducing your overall cycle time because you're not doing that pre-machining process. You also don't have to do post-machining. The net shape part comes out. You may have a little bit of flash from the resin in the pre-preg to trim, but that's it. Now let's say you wanted to have inserts in your part, like threaded inserts for attachment points. You can design your tool so that you can insert those inserts into the tool. The material, when it's heated, will foam around that and lock that into position. So now you have your inserts located at a very precise location where you don't have to go back in and machine holes and glue in inserts. So it cuts out that process as well. So that adds to the benefits as far as reducing cycle time, reducing material waste. You're able to achieve very consistent densities and avoid any kind of post-machining.
Jason, let's talk a little bit about the tooling side of things, if you don't mind.
Yep.
So what we have is an aluminum tool. We actually coated it. It's an Enduro coating so that we don't stick to it. And then we also vented that tool. So we would definitely suggest that you vent the tool. And it's not a lot. It's I think in this case it was 2/1000 of an inch vent channel. I forgot the width on it, but kind of radiating out from the outside perimeter. And
yeah, and that's especially important when you get into thicker parts, because as the foam is expanding, it's displacing the air in the tool. If there's nowhere for the air to go, you create that die lock, and the foam can't overcome the pressure in the tool itself. So, like Dennis mentioned, it's just a very small vent to cause a leak path for that air to escape, and that takes care of any issues with voids in the part or wrinkles at the surface where that air gets trapped.
And then maybe, Jason, let's talk a little bit about example parts. What type of example parts have we done in the last 6 months, let's say?
Yeah, so one of the tools that we made as a demonstration for these parts was a pickleball tool. We're not in the business of making pickleball paddles, but everybody knows pickleball is extremely popular right now. So we said, okay, how can we help customers, kind of visualize the benefits of the process, and also help some of the manufacturers out there that are making these kind of parts. So one part would be a pickleball paddle. We have both a thermoplastic and a thermoset version. I was looking in my box below because I had the thermoplastic one here yesterday, but this one will do. This one we just cut the handle off so that you can see the foam inside. It's a very, very closed cell structure. We've done water absorption tests on this material. We get 0% water absorption after 24 hours of submerging it in water. But the other benefit, and why someone may want to choose a thermoplastic versus a thermoset, is that it also can provide some vibration damping or acoustic damping properties. So if you consider a thermoset material, it's going to be much more rigid, and it's going to transmit the sound of the ball hitting the surface through the paddle. So you get a very loud kind of, that tinging sound. With the thermoset, it's going to deaden that sound, so you don't get that high pitch sound that a lot of people are complaining about when they have pickleball courts in their neighborhood. They're saying, oh, it sounds like a gun range over there. So we're thinking of ways, to help our customers solve problems. That's basically what L&L Products does, is we work hand in hand with customers on applications and try to solve their pain points. Another example would be in sporting goods as well, would be kayak paddle blades, all types of rackets, hockey sticks, lacrosse sticks, any type of a material that would traditionally be a foam core product. We also have some applications in wheels on race cars. We've done some heat shield applications. So this material, like I mentioned earlier, is also an adhesive. So in the example where you may want to have an aluminum layer on one side and a glass fabric layer on the other side, we've made parts where we've had the aluminum on one side, dry glass fiber on the opposite side. Our material expands, wets out that glass, bonds to the aluminum. You have a finished part with a very low weight. You can have variable thickness across the sample, just like when we made this demonstration for the dump tray. We're laying down a sheet that has a consistent thickness all the way across. And you can see in the part, there's a lot of different angles, a lot of different contours. That material expands and conforms and pushes the layers out to that surface. So you can make some very complex parts out of a consistent thickness sheet of material. The other thing is we have two standard thicknesses for the materials. We supply it in 2 millimeter thick and 4 millimeter thick. And then again, that material can be stacked. If you wanted to go to either a thicker part or create more pressure inside the tool, you can stack those layers up to do that.
So Ken is removing the tool from the press. He's placing it into a quench bucket, and he's going to cool that down. We're running which version for the demo?
That's the thermoset version.
The thermoset. So we're just going to make sure that we get that nice and cool so that it's not going to burn us.
Yep.
And then why don't we go ahead and...
I wanted to mention two other points before before we move on to the video. But the first is that you know, we're not dealing with any VOCs coming off of the material. You know, we don't have isocyanates like you would see with other types of foams and things like that. So it's a very you know, as far as environmental health and safety, it's a very safe material to work with. When handling the thermoset material, you know, you're going to want to wear latex gloves or something to protect yourself because it does have epoxy in it. So, but other than that, you know, no respirators or anything like that are required. The other thing I wanted to mention is we have the capability to make this flame retardant. We have applications in aircraft interiors where it has to meet the fire, smoke, and toxicity requirements, and it passes all of those. So, you know, if that's something you're doing or something you're interested in, you can come over to see us at our booth. We're just to your right at booth CC13, and afterwards, you know, you can come and ask questions one-on-one if you'd like. And then, Dennis, if you wanted to roll a video.
Yeah, let's roll the video and get that going.
All right, everybody. So Ken, he removed the tool from the water, and he's now unbolting the tool. We added a feature to this tool to make it easier to remove the part. We can actually unbolt the side. Because we coated this with the Enduro coating, we don't want to use any metal tools on that and scratch it. So he has just a plastic spatula and a rubber mallet to pop it out. Because the pressure locks it into that die pretty tightly. catch the edge of it.
Maybe talk a little bit about the pre-pregs and the limiting factor is not
Yeah, so you can see that when it expanded, it really pushes that out to the tool surface, and demolding it on this small of a part, you got to get in between that very small crack. There it goes. Once it pops out, you can see it's you know, it's a nice hard finished part. And as I mentioned earlier, you know, you have a little bit of flash that will come off just from the pre-preg.